Hello and welcome to Firing Base Metal Clay. I'm Wanaree Tanner. Metal clay is a malleable medium composed of superfine nanoparticles of metal, and to understand firing base metal clay, first it's important to take a little closer look at what it's made of. Now these superfine nanoparticles of metal alone are just a fine powder, and they can't hold themselves together. So an organic binder is mixed in. Water is also mixed in. This gives the clay its softness and workability, and floating all around in the environment is oxygen, which is actually a critical component to how base metal clay fires. This mixture is what makes the clay malleable, allowing us to roll out, texture, and cut different shapes and forms. The longer the wet clay is exposed to air and/or heat, it dries out. The water evaporates, leaving behind the binder and metal particles, and at this point, the clay becomes hard. That dried metal clay can then be sanded, altered, and combined with other clay pieces. But in order for the clay to transform into solid metal, we have to get rid of all the binder mixed in there. Fortunately, most binders burn off at about 650 to 900 degrees Fahrenheit. As it heats up, the binder consumes the oxygen as it incinerates. This leaves the nanoparticles of metal the space they need to come together. Now, if we were to continue heating this up, the base metal particles would react to the oxygen in the environment, especially at high temperatures, and the hotter the heat, the worse the oxidation effect. We have to protect the base metal particles by reducing the amount of oxygen around it. The best approach is to break this firing process down into two stages. First, we'll need a firing surface. A ceramic fiber firing board is ideal. It can be cut into smaller pieces that can be directly transported into a firing vessel. For larger work, place your work on the ceramic fiber board inside the kiln on lifted posts. Make sure to do this in a ventilated room. Leave the kiln vented as well, as some smoke will be produced while the binder burns off. Set the kiln to fire according to the recommended Stage 1 firing temperatures and times for the base metal clay you're using. If your clay isn't listed here, many manufacturers already include that in their directions. As the kiln heats up, the binder and oxygen particles begin to react. The binder consumes the oxygen and ignites, burning away, leaving the bronze metal. There may be a little smoke that comes out of your kiln at this point. Once the binder is burned off, you can see there's quite a bit of space between the metal particles. The bronze is quite fragile at this stage. We have to let it cool completely, but if you leave the vent open, cold air can rush into the kiln and may lead to thermal cracks in the semi-fired metal clay work, especially with more complicated and thicker pieces. Plug up your kiln and allow it to cool to room temperature for Stage 2 firing. After it's cooled completely, you can see the pieces emerge blackened. This is oxidation taking effect because you heated the piece. If you're firing delicate and fragile pieces, it's best not to pick them up. Instead, put the entire ceramic fiberboard right into the firing vessel. For larger work, place a piece of ceramic firing paper onto 2 centimeters of coconut firing carbon. Then place your work on top. The ceramic fiber paper will prevent the carbon from denting or damaging the surface of your piece. Then use a folded piece of stainless steel foil as a tent to keep the carbon from applying extra weighted pressure onto the piece. Pour 1 centimeter of carbon on top and place the lid over the vessel securely to keep the oxygen from entering the vessel as it heats up. Put inside the kiln chamber on kiln posts to allow for better heat circulation, with your work pointing to the back side of the kiln. This is where a majority of the heat will be concentrated. Close the door and leave any of the vents plugged up, and fire according to the brand and type of clay you're using. As the kiln heats up, the carbon and oxygen particles begin to react. The carbon begins to consume the oxygen inside the vessel and prevents any more oxygen from coming into contact with it. Set your kiln to take an hour or more to actually reach sintering temperature. When the metal clay finally reaches those temperatures, the particles become excited, move together, and bond. After the firing is complete, allow the kiln to cool down and remove the firing vessel. Now this piece is fully sintered metal and can actually be treated in the same way as any other metal piece. And here you can see after polishing, it's now luminous bronze. Now some brands and types of clay recommend a single-stage firing method. With this method you do everything at once, but it does present some potential issues. If there's not enough oxygen circulating throughout the firing vessel, the binder won't burn off completely, and it'll prevent the nanoparticles of metal from moving together as they reach sintering temperatures. You can adjust for this to some degree, but I don't suggest firing anything over 30 grams with this method. Don't put too many pieces in the kiln at one time while firing. You want enough room for the oxygen to circulate freely. Also, leave the firing vessel lid open or completely ajar so more oxygen can enter into the vessel. Also, leave the kiln vented for the same reason. And I highly recommend using an external pyrometer to monitor the temperature of your kiln. Feed the pyrometer inside the kiln and monitor the temperature as you fire. Now, as the clay heats up, the binder burns off, again igniting that oxygen, but it allows just enough oxygen in to ensure all the binder is burned off. Now the metal particles have the room they need to move together. And that's it. That's my method for firing base metal clay that I've used over numerous pieces throughout the years. Thanks for watching.